Welcome to the first exercise of projectile motion. As the name implies, we're going to look at projectiles. So the last video you saw me dropping something, that's a projectile. It doesn't have to be thrown sideways. You can just drop it. Anything that's dropped or thrown in the Earth's atmosphere is a projectile and undergoes projectile motion, and the kinematic formulas apply. So each one of you have got a tape. I dropped that thing 30-something times, and I gave each one of you a tape. But it would look somewhat like this. You have a start position, and I taped down the meter stick so it doesn't move, and I just taped the end of my tape so that it wouldn't move relative as well. Now, this meter stick has seen its better days. So I can't really read really well the first couple of centimeters, and it doesn't really matter. What you just want to do is take down the absolute positions. What we want to do is measure the distance between the dots. It isn't necessarily important for us to measure the distance absolutely, like from the very beginning. And as you can tell, when I start, I turn on that thing and it goes bzzz. And then I start dropping it. And once it starts dropping, the dots start getting a larger distance apart. Now the time between them is exactly the same, 1/40th of a second, one of your pre-lab questions. So the time it takes for the object to go from here to here is the same time it takes for the object to go from here to here, and the same time it takes for the object to go from here to here. But you can see the distance is increasing each time. That indicates an acceleration. So what we're going to do is just read off the absolute positions. Now I'm going to skip the first one. I'm just going to start with the second one here. So this is my 0, 1, and I'm labeling each of the dots. 2, 3, 4, 5, etc. So we'll label them as we go, but that's another thing you should do is label the numbers, and then all you have to do is put them in the spot in your data table. So for instance, the first dot, let's see if we can look at it a little more carefully. Look at it from above so you don't get a parallax error on it. So it is it's almost 5, but not quite. It looks like it is, I don't know, it actually does look like, I would say 4.95 centimeters. That's pretty close. So remember to convert everything to meters. That's 0.0495 meters. Point number 1, so we did 0, that's a starting point. Point number 1 is this one right here. That looks like it's right at 6.1. 6.1, 0.061 meters. Point number 2, let's see, 8.56. That looks like 8.7, right? 0.087 meters. Now, again, just keep labeling them. You're going to have different data than I will, okay? You have different dots, and your meter stick's going to be at a different spot. So that's okay. You have your own data. It's not going to match my data. Do you understand that? You got to write down your own data off this tape. So what I'm going to do is I'm going to pause the video, and we're going to give you some time to go ahead and do that. Take the data. You want to have 16 dots altogether, dot 0 through 15. So take the data right now, and then we'll go on and do the rest of the analysis.